In this video, we'll focus on and inequalities, but also solving and writing the solution sets in set builder notation. So we'll look at three examples here. Let's begin with the first one. For the first one, you see that word and. If you see the word and, you're going to solve each of the inequalities separately, but then when you have your inequalities on each side with the variable isolated, you need to either graph it or think about the overlap. You have to do the intersection. For the other two examples, we don't see the word and, so we'll have maybe a little bit less work in some sense to do for those. Let's take a look at that first one. So again, you see that word and, we're going to solve each of these individually. So for the first inequality, I'll isolate the 7x on the left side by subtracting 2 from both sides. 7x is greater than or equal to 7. By the way, don't lose your inequality symbols. One common mistake is to turn them into equal signs. Be really careful with it. Always make sure that you're writing everything out. So go slowly if you need to, or say it kind of mentally if that helps. Continuing, I'll divide by 7 on both sides. X is greater than or equal to 1. For the other inequality, I'll subtract 3. 4x is less than or equal to 4. Divide by 4 on both sides. Here I have x is less than or equal to 1. So don't forget that this was an and. It's still an and. So I'm still writing my compound inequality. If I'm writing this in set builder notation, the set of all x such that x is a real number, x is greater than or equal to 1, and x is less than or equal to 1. Now that's a little funky, so let's do the graph. We might be able to simplify this a little bit. So let's take a look at the graph. I only have one number, 1. One side says x is greater than or equal to 1. The other side says x is less than or equal to 1. So if I were to kind of graph those both on the same number line, but think about where they overlap, I would have the following. So for this one, x is greater than or equal to 1, but it would include 1 and shade to the right. For the other, x is less than or equal to 1, I would include 1, but shade to the left. So the only value that is included, or the only place where the shadings meet, is at 1. So my graph would only have one value shaded in, 1. You could, probably the best way to represent this would be a closed circle, since it's just one point with no shading. So closed circle at 1, that is my solution set. I can write that as an interval. 1 is the only number, 1 is the biggest and the smallest. Sorry, make that a 1 here. So they're both 1s, 1 comma 1 with brackets around them. That's just that one number. Which means that I could actually simplify my set builder notation here. The set of all x such that x is a real number and x is equal to 1. So we had to do some work. We had to find the overlap in order to get that solution set. All right, now that's the case if we have the word and, right? We have to, the graph really helps, to find that overlap. On the second two cases, we don't have that word and. In fact, the inequalities are kind of written as one statement instead of two. So the strategy that we're going to use to solve is going to be slightly different. We're still going to try to isolate the variable, use addition, multiplication principles, worry about if we're dividing or multiplying by a negative. But I want to keep the variable in between the inequality symbols. So my goal is to isolate the variable between the two inequalities. Kind of think about this as 3 sections, right? Same thing here. I have 3 sections. Keep the variable in the middle. Let's take a look at that second one. So my goal is to get the x isolated but in the middle section here. If you want, you can kind of think about these three regions, just kind of drawing vertical lines where my inequality symbols are. I want to get rid of this constant, the 2, so I'm going to subtract it, but I have to do it now 3 times for all 3 regions. -12 minus 2 is -14. Bring down your inequality symbol, is less than. Now I have 7x. Bring down the other inequality symbol, less than or equal to. 6 minus 2 is 4. Again, I want to keep that x in the middle. Divide by 7. -14 divided by 7 is -2, which is less than x, which is less than or equal to 4/7. I can't simplify that. So because the inequalities were already joined, the overlap has already been done for us. We can go ahead to the graph. And -2 is smaller than 4/7 because it is negative. X is between these two values. It is not equal at -2. It is equal at 4/7. So I will go ahead and put parentheses around at the 2, brackets at the 4/7, and shade everything in between. If I wanted to write this in step builder notation, I could use the compound inequality that I have here, the set of all x, such that x is a real number, and -2 is less than x is less than 4/7, less than or equal to 4/7. As an interval, -2 comma 4/7 with brackets. In the last example here, we have that same idea where the two inequalities have already been intersected, overlapped, and we're going to isolate the variable in between the inequality symbols. Here we have fractions. So let's take a look how to deal with the fractions. It's really the same thing that we've done before, so we can clear out fractions or clear out that denominator. Even think about that as this means divide by 3. The opposite of dividing by 3 is multiplying by 3. But I'm going to do everything 3 times. So I'll multiply every side by 3. So times 3, take this whole thing, multiply by 3, multiply this by 3. By the way, if you are multiplying or dividing by a negative, you do have to change the direction of both inequality symbols. In this case, 3 is positive, so I don't have to worry about that. So then my inequality reads -12 is less than or equal to, the 3 here cancels with the 3 below, so I have 4x minus 3 in between is less than 9. Again, my goal is to get the x in that middle section, so I'll add 3 to all 3 sides. -12 plus 3 is -9, is less than or equal to 4x, which is less than 12. Dividing everything by 4. 4 is positive, so I don't have to change any inequality symbols. -9/4 can't be simplified, is less than or equal to x, which is less than 3. And I don't need to do the intersection because the overlap is already done. If I wanted to write this in step builder notation, we have the set of all x such that x is a real number, -9/4 is less than or equal to x is less than 3. To get a picture of what this looks like, -9/4 is smaller, it goes on the left. I'm shading in between. I only know that again because the overlap is done already and is not always in between, it's where the two shadings meet. -9/4 is included, so I have a bracket here. 3 is not included, so parentheses, shading everything in the middle, and my interval would be bracket -9/4, comma 3 parentheses. And again, if you wanted to check your solution set, you could pick any number in the shaded region, plug it into the original, see if it makes the statement true. If I wanted to pick an easy number, in this case, because I'm between a negative and a positive, I could pick 0. Put 0 in for x, simplify, see if the statement is true on both sides. If it is, you're good. If it's not working on one of the sides, double check. Start over, make sure everything is good to go.